it should be all right now. Am I audible now?
Yes, sir.
Yes, yes, sir.
Am I?
Yes.
Yes, sir. Now, yes.
Yes.
Oh, so now it is okay, right? So we in the morning we spoke about CPCPK as well as PPPK. You understood the clarity and most manage the given scenario, isn't it? How to manage the given scenario? We'll go with the best possible approach, isn't it? Within the timeline, within the limitation, whatever is the best, we do it. And even the sample size can now be managed. If you think the number of samples you can collect is can only be minimal, then go for using standard error as a measure of the variation or as a measure of the uncertainty. Don't just settle with the standard deviation, rather you go with the standard error. All of you understand the purpose of, now you know there are three types of variation. One is variation in the population, another one is variation in the sample, and one more thing is variation in your sampling average. You understand? Am I correct? If you can control the variation in the sampling average, it is as good as the controlling the total variation. And that's why even with the less sample, you can better understand the variation and get a picture of what's happening close to the reality.
Outside, lot of
Lot
disturbance is
of
there.
background noise, sir.
Yeah. I think from Raghavinder, you have to stay muted. A lot of noise is coming. All right. So now,
sir, I am in a hospital. That's why I'm muted. Just I am listening.
yeah. You please continue listening, but then
Okay.
stay muted.
Okay.
All right. So now we are going to learn another interesting tool, which is called design of experiments. So studying the factors one by one, we know we have already understood the subject, null hypothesis, alternate hypothesis. Everything will be there here also in DOE also. But the only difference is we'll study the factors simultaneously. If there are three factors, we study all the three together. If there are two factors, we study all the two factors simultaneously. The advantage is you will not only be able to study the effect of the factor, you will also be able to understand the effect due to the interaction of the factor. The effect due to the interaction of the factor. So what is interaction? If an interaction is present, the factor will start behaving in a different manner. The factor will start behaving in a different manner. Normally, it will behave in a particular manner and then influence your Y. But when there is an interaction, the same factor will influence your Y differently. Have you ever noticed this kind of scenario? Have you ever noticed this kind of scenario? A factor influencing Y in a particular manner, same factor will influence your Y in some other manner. Have you noticed this kind of scenario? Am I audible?
Petrol prices, sir.
Yes, sir.
Petrol prices, example.
Example.
Petrol prices.
Come again. What is that you are saying?
Petrol prices.
Petrol.
Oh, petrol prices. Okay, petrol prices. Okay, can you explain how the petrol price can be used to understand interaction?
Because it is interlinked with our other transportation and our regular costs and other things, right? One varies, other also it influences others. Like
Okay.
1 rupee it is increased. Everyone try to increase on behalf of that 1 rupee increase. Though it is
Very
not
good.
affecting to them, but really it will affect to us as a consumer.
All right. So let me give one more example, simple example. Let's consider your productivity. How productive you will be on a daily basis, right? You know what
Yeah,
are you
correct.
doing, right? Morning, the morning 9 o'clock you start the work, and evening 5:30 you close the work, and your productivity is our Y variable. Your productivity when you are in office and your productivity when you are in house. Will there be a difference?
Yes.
Definitely. Yes.
Same factor,
Yes.
but there is a difference in the productivity because in the house you can see your wife standing nearby. In your office, you will have other people in your nearby. So in the presence of your wife, your productivity is expected to increase or decrease?
Decrease.
Decreases.
Decrease.
It again depends, right? Okay.
Yeah.
In some cases it will increase, in some cases it will decrease. So that means the presence of other factor. Oh, sorry, I think again internet issue. The presence of one factor influence the effect of another factor. You normally achieve 80% productivity. But when you work from home, your productivity is going down by 10% or going up by 10%. This plus or minus 10% is due to the interaction of another factor. What is the other factor? You working from office or you working from home?
Home.
The environment, the factor is environment. Isn't it?
Environment. Yeah.
When environment also comes into picture, the outcome or the effect of the factor, which is known as main effect gets affected positively or negatively. If
Negative.
it gets, yeah, negatively, yeah, okay. It can get affected positively, it can get affected negatively. In both cases, it is known as interaction. That means interaction can be positive, interaction can be negative. If interaction is positive, allow the factor to interact. If a person's productivity can go up by working from home, company can decide to allow the particular employee to work from home because his productivity is going up. Interaction is positive, so you are allowing the factors to interact. Suppose if interaction is negative, if the productivity is very low, you could have seen the company calling the employees to come to office because they know the interaction is negative.
Negative.
So now we learned one thing. There is an effect every factor will have. Am I right?
Yes.
There is an effect every factor will have on your y variable. That is known as main effect. That is known as main effect. We all want to optimize the effect. Optimize means if it is needed, we maximize it. If it is not needed, we minimize it. Right? One is main effect, and one more thing is interaction effect. If the interaction is positive, I want maximum value. You know what will I do? I will allow the factor to interact. Over and above the main effect, I'll get some additional bonus when I allow certain factors to interact. Am I correct? Yes or no? When I allow certain factors to interact, I will get the result over and above the main effect. If the interaction is negative, I'll see to that the factors are not allowed to interact. So let's understand this concept with some more examples in my slide. I think that can bring more clarity. Let me straight away. Okay. So to again better understand the concept of interaction, let me give one more example before sharing this slide. Imagine a doctor has to operate a patient. Doctor has to operate a patient. So they used to give anesthesia, right? Doctors are also here. Anesthesia. Imagine if an anesthesia is given, it will work for 2 hours. It will work for 2 hours. So within the 2 hours, you may have to complete the operation or whatever. And then the person will become conscious. So if I give the anesthesia, what do you call, sir? The person will become unconscious, right?
Yes. Yes.
Is my wording correct? Doctors can correct me. All right. Okay, the person is unconscious for about 2 hours because he is given an anesthesia. This is called main effect of the anesthesia. Correct? This is called main effect. Imagine the patient has to necessarily take an antibiotic during the time of, the anesthesia, giving anesthesia. Now he takes antibiotic A as well as he is given the
Anesthesia.
anesthesia. So now also the anesthesia works the same manner. It gives 2 hours of, the unconsciousness. That means the antibiotic A and the anesthesia are not interacting. Am I correct?
Yes.
They are not mixing up and the effect is clearly, separate. The effect of the anesthesia is not influenced by presence of the antibiotic. But in another occasion, for another patient, antibiotic B is given while giving the anesthesia. Now what happened? The operation time is 2 hours. And the anesthesia is also given for 2 hours. But because antibiotic B is also given, anesthesia is also given, the person is in a state of unconsciousness for only 90 minutes. Now he is given the anesthesia along with antibiotic B. Normally anesthesia will work for 2 hours. But now it is working only for 90 minutes. The person wake up in the middle of the operation. Tell me what happened, how this can happen.
Right. Anesthesia and
Drug interaction.
Yeah, the doctor should have avoided antibiotic B.
Mm.
Because antibiotic B was present, it was suppressing the effect of the anesthesia. The normal effect got reduced. The interaction is positive or negative this time?
Negative.
Negative. So as an analyst, you should know, or as a researcher, you should know how many effects are there, first of all. How many effects are there? If you have an output variable Y, and if there are multiple factors, let's say X1 and X2 or A and B. One factor is A, other factor is B. Now A will have a main effect. Am I right?
Hmm.
B will have another main effect. So 2 main effects are there. 2 main effects are there. Over and above, A and B can interact. And there can be an effect due to interaction. That is called interaction effect. Just now we understood that interaction effect is also important to be understood. Otherwise, something unexpected will start happening in your result. Like the patient, waking up in the middle of the operation. That should not happen. So main effect due to A, main effect due to B, and then interaction effect. 2 factors, but 3 effects. Can you see that? 2 factor, but 3 effects. So far, we thought that there are only effect due to 2 factors and there are only 2 effects. The third factor was completely invisible, but after understanding interaction, even though there are 2 factors, how many effects are possible? 3 effects are possible. What are they? Effect due to factor A, effect due to factor B, and effect due to interaction between A and B. A is main effect of A, main effect of B, and the interaction effect is denoted by AB. A means effect of A, B means effect of B, and AB means interaction effect. If there are 3 factors, A, B, and C, there will be main effect due to A, there will be main effect due to B, there will be main effect due to C. Over and above, A and B can interact together.
Yes.
B and C.
B and C can interact together.
ABC.
A and C
Yeah.
can interact together.
ABC.
And all the 3 can interact together.
Together.
Four interactions over and
Will
above 3 main
3.
effect. Totally how many effects?
7.
7.
7.
7 factors are affecting your output. But we have been talking only about 3 factors. How 3 has become 7? 4 of them are invisible. 4 of them are invisible.
Invisible.
But those invisible factors can be controlled through your visible factors. The invisible factors can be controlled through the controllable visible factors. Yes or no? If I cut the antibiotic P, automatically interaction will be avoided. Yes or no?
Yes.
Or I can minimize the power of antibiotic P. If I minimize the power of antibiotic P, then what will happen to interaction? Interaction will get
Interaction will
reduced.
come down. Come down.
So you are able to minimize the interaction. You are able to maximize the interaction by adjusting the factor, by adjusting the level of the factor. If I give antibiotic A 250 milligram, I also have an option to give antibiotic 500 milligram. 500 milligram means level is high. 250 milligram means level is low. Every factor will have levels. Am I right?
Yeah.
Every factor will have level. Like temperature can be high, temperature can be low. Pressure can be high, pressure can be low. Pressure can be moderate also.
Yes.
When I have low, moderate, high, how many levels I am talking about?
3.
3 levels. So now you are understanding certain things. There is factor, there is interaction, and every factor will have an effect, and every possible interaction will have an effect. An effect can be positive, effect can be negative, and factors will also have levels. Every factor will have levels. By adjusting the levels, I will be able to adjust the interaction. By adjusting the levels, I'll be able to adjust the interaction. So with this knowledge, you can actually optimize any output variable better than a traditional researcher. Am I right?
No.
A traditional researcher, a traditional analyst, but we are going to analyze for the main effect as well as main effect as well as for the interaction effect. All right. DOE. Now tell me, if there is only one factor, will there be interaction?
No, sir.
No.
For interaction, minimum 2 factors
2.
are required.
Perfect.
Minimum 2 factors are required for the interaction. All right. So now let us take an example. A case of an aircraft industry where the aircraft components are painted. Aircraft components are painted. We want the paint quality to be better. Yeah, paint quality must be better. So how can I measure paint quality? Can you give me a suggestion?
Coating
I want to
Thickness, DFT.
coating thickness.
Yeah.
What is that? DFT. Yeah. DFT means?
Yeah.
Yeah,
Dry film thickness.
Dry film thickness.
Okay. So there is a way by which you can understand the paint strength, which is known as adhesive strength. Am I right?
Yes.
Yeah, yeah.
The adhesive strength of the paint. And the company knows that the adhesive strength depends on the type of primer that is used and the type of painting method that is used. Adhesive strength is my output, Y variable.
Yeah.
Type of primer is one factor. Type of painting method is another factor. So how many factors are there in this problem?
2.
2 factors. It's a 2-factor DOE. And after DOE, it will become a case of two-way Anova. For analysis purpose, we'll use a method called two-way Anova because there are 2 factors. Now, primer 2 and primer 3. That means factor number 1 has got 3 levels. Am I right? Factor number 1 has got 3 levels. What are the levels? Primer 1, primer 2, primer 3.
Your voice is not coming, sir.
Form. Oh, not all. Sorry, I think there was a connectivity issue again. Am I audible now?
Yes, now yes.
Am I audible now?
Yes, yes.
Now
better.
okay, now okay.
Am I
No, again.
audible now?
Again, there is a disturbance, sir.
கேக்குதா நான் பேசுறது?
Yeah,
Okay,
yeah.
sir. Okay.
என்னாச்சு? net ஏதோ இல்ல. Is it okay now?
Yes.
Yes.
Okay, tell me where I got lost.
Last 30.
Anova
40
two
seconds.
factors
Primer.
case
And
study.
over.
Two-way Anova. Okay.
With
I
three
was
primer
talking
exam.
about, I was talking about two-way Anova because there are two factors. One is type of primer, other one is type of painting method. And primer, there are 3 types of primer: primer 1, primer 2, primer 3.
Primer 3.
And painting, there are 2 types of painting. One is dipping, another one is spraying. So first factor primer has got 3 levels. Second factor painting method has got 2 levels. So minimum level of the first factor is 3, level of the second factor is 2. Minimum 6 experiments I have to do because 6 combinations are possible. How do I know the total number of combination? 3 into 2. So how many experiments minimum I have to do? 6 experiments. So at least 6 sample pieces have to be painted to understand the possible combination. Primer 1 painting, sorry, primer 1 dipping, primer 1 spraying, primer 2 dipping, primer 2 spraying, primer 3 dipping, primer 3 spraying. So minimum 6 experiments you have to do. The total number of experiments can be calculated just by multiplying the levels of all the factors involved in your study. In this case, 3 into 2, 6. One more important thing in DOE, you should always replicate an experiment. You should always replicate. You remember,
An experiment.
yeah, you remember we already used the word replication while discussing about gauge R&R. Am I correct? Am I correct? Gauge
Yeah.
R&R. While discussing
Yeah.
gauge R&R, yeah.
Minus
So, if you don't replicate, you can't find out the repeatability error. If there is no replication, then repeatability error cannot be understood. Similarly, while conducting DOE, if you want to minimize the experimental error, you have to replicate your experiment at least twice. Understand, all of you? When I say replication is 2, each experiment must be performed at least 2 times, not back to back, but in a randomized manner. When you do back to back, it is known as repetition. But if you repeat the same experiment in a random manner, in a way that the person who is conducting the experiment himself should not even know that he is repeating the experiment, then it is known as replication. All of you understand replication? What is the purpose of replicating the experiment?
To
To understand.
minimize the
Yeah. Ultimate goal is
Error.
minimize the experimental error.
error.
If you replicate and if there is a difference in the reading, that is called error. I replicate the experiment, but I get two different readings. Why I get two different readings by conducting same experiment? That's the error, experimental error. So in order to estimate the experimental error, you have to replicate. If I assume replication is 2, then my number of experiments will become 12. You understand? Number of experiments will be 12. Now you have to do 12 experiments. If I make the replication as 3, then how many experiments I need to conduct?
18.
18
30.
experiments. 18, 6 into 3.
18.
Now, can you conduct all 18 experiments on a single day? Do you have the facility? Let us say in your facility, in a day, you can only conduct 6 experiments. Am I right? So, your experiments will go on for 3 days.
3 days.
Now, each day is known as a block. A set of experiments performed in a group is called as a block. Now, how many blocks are there in our experiment?
3 blocks will be there.
6.
3 blocks.
If you do 3
Block,
days. Yeah.
block number 1, block number 2,
Block number
block
2.
number 3. Block number 1 is day number 1. Block number 2 is day number 2. Block number 3 is day number 3. And inside every block, we have 6 experiments. Sometimes they call it trials or the runs. You understood 2 things here, all of you. One is replication. Another one is blocking. When you do the blocking, you need to be very careful on one thing. Block should not become a factor. Do you understand what I'm speaking? Block should not become a factor. Let us say one day there was a heavy sunlight. The other day you conduct the experiment, there was a heavy rain. Do you think this situation will affect your experiment?
Yes.
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 There will be a difference in your readings of day 1 and day 2. Day 1 and day 2 will have a big difference because one day there was a heavy sunlight, the other day there was a heavy rain. That will affect your experimental output, and the source of variation is the nature of the day.
Environment.
The nature of the day during which you conduct the experiment is also becoming a source of variation. That means block is also acting as a factor. Am I right? All of you understand?
Yes.
You have to block your experiment in a way that blocks never become a factor. Otherwise, your analysis will become too complex. You may not be able to find out, why the effect is getting, why the output is getting affected. All of you understand the point I am trying to say? First thing
Yes.
is replication. Why we
Second thing is
replicate?
block.
Yeah. Why we replicate? Because we wanted to minimize the
Experimental
error due to experimental error. And number 2, we divide the blocking because there are constraints, resource constraint. Sometimes you will have only one experimental setup and you have to do 100 experiments. You can't do all 100, in just one setup within 1 hour. Not possible. Some experiment will happen today and some experiment will happen other day. Sometimes experiment will happen for 3 months. You have to make sure your blocks never act as a factor. One important, these are principles of DOE, replication, blocking. And the requirement is blocks must be homogeneous. What is the requirement? Blocks must be homogeneous.
Homogeneous.
How the experiments are conducted in a particular block, the same way only the other blocks should also be conducted. Otherwise, your block will also become a source of variation, which must be avoided. Already we are trying to solve a complex problem and we should not, invite additional complexity by violating these principles. Third principle, randomization. Third principle is randomization. Inside the block, you are conducting experiments, right? The order of the experiments should be completely random. The order of the experiments must be completely random. Why randomization is required? Randomization will minimize the bias. Am I correct? When I randomize the experiment, bias will get minimized. Am I correct or not?
Yes.
If I ask you to do 3 experiments, same experiment 3 times, and obviously, no, people will no, feel boring doing the same work 3 times. Yes or no?
Yes, yeah.
We'll give the readings 3 times instead of, oh, again, I think there is a network problem. Yeah. So I was talking about randomization.
Randomization.
So yeah,
Bias.
when you randomize, the bias will get minimized. Otherwise, there is a chance that someone can do the experiment just once and give 3 readings. Possible or not?
Yes.
Possibilities are there. So 3 important principles needs to be followed. One is replication
So
to
blocking,
minimize experimental error. Blocking, blocks
Blocking
must be
or
homogeneous.
randomization.
And
homogeneous,
randomize the
Randomization.
experiments inside
bias
each
will be
block.
nice.
This is to minimize the bias so that your readings can be more accurate. All right. So with that, we are now going to this problem. The data is also available in the Excel file. And look here, addition force is your Y variable. All of you can see that, which is a continuous variable. Factors, there are 2 types of factor. One is primer, another one is painting method or application method. These are discrete factors or attribute factors. Because primer, there are 3 discrete possibility. Primer 1, primer 2, primer 3. And application method, dipping and then spraying. That
Spraying.
means number of levels for primer is 3. Number of levels for application method is 2.
2.
Look here, how many experiments are conducted?
3.
3,
1 and
here 3,
3.
here, no,
3.
every combination 3 experiment. So totally how many experiment?
18.
18.
18 experiments. 18 experiments are conducted, 18 readings are available. Each reading talks about the addition force. Am I right?
Yes.
Quantum of adhesive force required to peel the painted layer. All right. All of you, are you getting my point?
Yes.
Because your Y is adhesion force. So every number here is a measure of adhesion force. Now,
Say voice again interrupting, sir.
Voice gone, sir. Voice is not there. Audio is not there, sir.
They're not clear. Not clear, sir. Voice is breaking.
Voice, we are not unable to hear you, sir.
So, RK sir,
So now clear, sir.
now clear. Okay.
Now it is clear, sir.
RK, okay. All right. So So I was talking about how the DOE will happen and the difference between DOE and ANOVA. ANOVA means analyzing the data to understand the effect. That is ANOVA. Data is generated. Now you have 18 data points. We follow a specific procedure to analyze the significance of each of the effect. To analyze the significance of each of the effect. That is called ANOVA. There is a procedure, and you don't worry about the procedure, and they will handle the data in a particular manner. They will add it, they'll square it, they again subtract, they divide, and all these mathematical activities will happen. And ultimately, this kind of values will be arrived, and then that will be tabulated. This table is known as ANOVA table. This table is known as ANOVA table. And after you construct the ANOVA table, you can see the last value is p-value. The last one is p-value. And if the p-value is less than 0.05, that particular factor is significant. If p-value is more than 0.05, the factor is insignificant. So the analysis you do is known as ANOVA. But the whole exercise you are doing is known as design of experiments. Experiments are conducted, outcome is tabulated, ANOVA is done. After the ANOVA, with the available information, you have modeled the problem as a mathematical equation. What do you call it as? Regression equation. All of these things, if you do, that is called design of experiments. Finally, why do you frame the regression equation? Any idea?
R square. Sorry.
Why should we frame the regression equation? Tomorrow, if you want,
Minimize the optimism.
yeah, suppose in the future, you want to understand if my y changes to different values or different possible values of x, for different possible values of x, what will be my y? Now there are two options. One more time I can conduct the experiment, or otherwise, if I have a mathematical equation, without even conducting the experiment, I can find out the output, isn't it? So the one purpose of regression equation is to prediction. After conducting sufficient number of experiments, you don't have to conduct further experiment. Keep the equation with you for different values of x. The equation itself will give you y, because DOE is a costlier activity. Every time you do an exercise, lot of money is involved. So you can minimize your experimental expenses if you have a mathematical model of it. And moreover, having a mathematical model can also talk about the quality of your whole exercise. If you have a regression, that will have R square, isn't it? That will have R square. That R square will talk about the quality of your data and the quality of your whole exercise. That's the purpose of having the regression. So now, see here, going back. Now tell me, this number 49.6 is, sorry, the number 40.2 is nothing but sum of the first column. What is this number? 49.6? Sum of the
spraying.
second
Yeah.
column.
Column 2. Yeah.
Adding all the numbers under the heading spraying. Now, this number 28.7 is nothing but sum of these 6 numbers. Can you see that?
Yes.
Yeah.
Similarly, sum of these 6 numbers is this. Sum of these 6 numbers is this. Column-wise total, row-wise total. That's why they are known as column total, row total.
Okay.
Now, all the 18 numbers, when I add, that will give 89.8.
Okay.
What is 89.8? All
Like
the
it is
18 numbers
skipping and
added.
saving, yeah.
That will be equal to column total, sum of column totals, or sum of row totals. Either way it is. So there is some mathematics happening. You can gradually learn on that if it is required, or otherwise you can look at the result and then take effective decisions, right? I'm not going to explain everything here because when it is required, you will come back to me. I will explain that point of time. You will be in a better state to listen to me, but not now. All right. So now there is something called correction factor. What is the formula for correction factor? Can somebody read out?
Square by
GT
GT
square by
square by
by
18.
18.
So GT, what is GT? Grand total.
Grand total.
Grand total is how much?
89.8.
Square that and divide by 18. What is 18? Total number of
Number of
experiments.
experiments.
Total number of experiments 18. So 448.0022 is known to you. Now, total sum of squares. What is total sum of square? Every reading must be squared and that must be summed up. How many reading you have?
18.
18 reading.
18 reading.
Square every number, sum them up. That is called squared sum. Minus correction factor.
Correction
That
factor.
will give you a value known as total sum of square, or shortly called as SS total. SS total means total sum of square. What is the only we subtracted? Correction factor. All of you are with me? All of you are with me, please.
Correction.
Yes. So
All
what
of
is
you
correction?
understand how this value has come? One is
Yes.
correction factor. That's why I'm asking. Okay. So is it better now? Getting better?
Yeah, now okay.
Yes, yes.
Okay.
Yes, yes.
Now okay. Now okay. Thank you. So I was explaining about correction factor and now I am explaining about total sum of square. Total sum of square is nothing but sum of squares of individual numbers
Individual values.
minus correction factor. 18 numbers, you square individually, sum them up, subtract correction factor. The resulting number is known as total. Clear?
Yes.
Yes, sir.
So where is CF?
Clear? Again a problem.
Correction factor.
So correction factor, where is the value?
Is it clear to you?
Yes.
448. Correction
Okay.
factor.
Yeah. Correction factor
yes.
is correction factor is
448.
448.
Yes.
And
minus
then
CF.
total sum of square is 10.7. Now
Okay.
sum of squares for the primer. Sum of squares for the primer.
Minus.
Now row wise, you have to square and then sum. So row wise, how many numbers you have? First row 28.7.
Yes.
Second row 34.1.
34.
Third row 27. Please square
Yes.
them, sum them, and for each total, how many data you have used?
6.
6
So divide by 6 minus correction factor.
Correction factor.
Don't worry about this procedure. Time being, just listen to me. You are able to understand something. That is good enough because I want you to use Minitab or our template. Don't do it manually, but you can learn it little later. Now,
Okay.
sum of squares for the method. Method means column wise. Now you have 2 data point, right? First column 1 data point, second column 1 data point. Square them, add them. Can you see I am dividing by 9? You know why? This is a total of how many numbers? 9 numbers.
9 numbers. Okay.
Square the numbers, add them, divide by 9 minus correction factor. You get 4.9. Clear all of you?
Right.
Yes, yes.
Sir, but
Now-
for SSC, it should be square sum of column, right? Again, it is row.
SSC, sum of squares for the column. You can also call it sum of squares for the methods. There are 2 methods. That's why there are 2 columns.
So
But
in
the formula is given as
description, it is written row. That is the reason he's asking. It should
Second
have
one.
column.
SS method.
You're
Yeah,
right.
here
You are
column.
right. You are right.
Sum
You are
of
right.
column.
You are right.
Yeah.
Squared sum of columns. Very good. Sorry. This is a mistake. Copy paste
Yes,
and
here,
I forgot
here.
to edit.
Yeah,
Error. Yes.
column.
Error inside error. Okay. So 40.2 squared, 49.6 squared, added and divided by 9 minus correction factor. Now finally, sum of squares for the interaction. So for interaction, we are using this particular area. Here what we do is 12.8. You know what is 12.8?
L total.
L total.
First cell
That
total.
4,
First
4.5,
method.
4.3.
First cell.
Primer one dipping combination 12.8.
Yes.
Can you see that?
Yes.
Primer one spraying combination 15.9.
15.9. Yes.
Primer 2 dipping 3 data point. Primer
Yes.
2 spraying 3 data point total. Similarly, primer 3 dipping, primer 3 spraying. So you have 6. With the help of these 6 sum values, we are going to find out the sum of square for the interaction. Squared sum of cell total. That means everything must be square and then you have to add them together. Then divide by 3. Why it is 3? Because every value,
Three primers.
Number of primers.
sum of 3 values. So divide by 3 minus correction factor. Please note minus correction factor minus sum of squares of the rows, sum of squares of the column. That is coming out to be 0.241111. Clear?
Yes.
The method
Yes,
is clear, but you don't have to worry about why so much thing we are doing. That is required. That is a procedure that is coming under a title called Anova. Right? Now, finally, error. Error means somewhere here you have total sum of square. Total is how much? 10.7. Then there is sum of square due to row, sum of squares for row, SSR, sum of squares for column, sum of squares for interaction. So 10 minus 4.58 minus 4.9 minus 0.24. The balance is 0.98. All of you understand? This is total.
Yeah.
This is primary effect. This is painting method effect. This is interaction effect. Even after subtracting all the effect, I could still see some variation. The balance is error. Hope I have done my best to explain you this table. Am I right?
Yes.
Very
Yes.
good. So with this value, all of you can construct the ANOVA table yourself. So what is ANOVA table? First column talks about factors. How many factors are possible? Primer is a factor. Correct?
Method is effect. Interaction effect.
Painting method is another factor. Interaction is third factor. Interaction is third factor. Then total effect. Total effect. The difference between total and the effect of all the factors, that is considered as error. All of you understand?
Yeah.
Primary effect, method effect, interaction effect,
Interaction effect.
total effect, error effect. Now the sum of squares values must be listed against each of the factor. For primer, it is 4.58. Am I right? Can you see here?
Yeah.
For painting method, how much it is?
4.90.
4.9.
4.90. For interaction, it is 0.24.
0.24.
Then for error, it is 0.98. Now total, you simply total all the 4. This will come here, or otherwise you can bring it from here. 10.71. Both are same. Second column is understood. Sum of squares.
Yes.
How to read this?
Yes.
Sum of squares. How to read this? Sum of squares for primer, sum of square for method, sum of squares due to interaction, sum of squares for error, and this is total sum of square. You all know how to read it. Now degree of freedom. Primer, how many primers are possible? How many types of primers are involved?
3.
3.
So 3 minus 1, 2 is the degree of freedom for the primer. All right. Number of levels for the factor minus 1. N minus 1. That is known as degrees of freedom. Now methods. How many methods are possible?
2 methods.
Yeah. Two methods.
So degree of freedom is 2 minus 1, 1. Now interaction, degree of freedom for interaction. Interaction for A and B is A multiplied B, AB, isn't it? Same manner, degree of freedom, you multiply these two degree of freedom. 2 into 1, 2.
2.
Now, total degree of freedom. Totally, how many experiments you conducted?
18.
18.
So 18 minus 1,
17.
17 is the degree of freedom, total degree of freedom. Now this has to be filled up. Total degree of freedom minus degree of freedom of all the factors. When I subtract,
5. 17 minus 5.
remaining
17.
is known as degree of freedom for the error. 17 minus 2.
Sir, we lost you,
Problem
sir.
with the network.
Lost your.
Sir, we lost you, sir.
17 minus 5,
Is there
12.
a problem with the network? Is there?
Yes.
Yeah,
Yes, yes, yes.
I'm just holding on. Am I okay now? Am I okay?
Yes, sir. Yes, sir.
Yes, yes.
Not audible, sir.
Very poor signal.
Now clear, sir.
Now is it better?
Yeah, yeah.
Yeah.
Yes, yes.
But still it is showing low. Okay. If you are feeling better, okay with me. All right. So I was talking about degree of freedom, degrees of freedom. So for the primer, it is 2. You all know why it is 2. Am I right?
Yeah, yeah.
Yes.
You all know why it is 2. For method, why it is 1. How to find out the degree of freedom for interaction?
2 into 1.
2 into
2
1.
into 1. Now total degree of freedom, how to find out?
18 minus 1.
18 minus 1.
18 minus. Yeah.
18 minus
Beautiful.
1.
Beautiful. Now how to get this 12?
17 minus
2
5.
minus 1
5.
minus 2.
17 minus
17 minus
5.
5.
Excellent. 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 Now we are moving on to the next column, which is called mean sum of squares. Here it is sum of squares for the factor. Here it is mean sum of square. Mean sum of square is nothing but sum of squares divided by degree of freedom. 4.58 divided by 2. How much it is? 2.29.
0.29.
4.90 divided by 1. 4.90. 0.24 divided by 2. 0.12. 0.98 divided by 12. 0.08. You don't have to calculate here. Now mean sum of square for primer, method, interaction, error is obtained. Clear all of you?
Yes.
Yes.
Now going to F score. F score. Please understand. We are now using a statistics called variance. What is the statistics we are using now? Variance.
Variance.
When you square all the squared values we are using, you have seen that,
Yes.
isn't it? That means we are trying to measure the variance. So variance between the factor divided by variance within the factor. This ratio is known as F score. Variance between the factor. For example, variance between the primer is available here. Variance within the factor, that is known as error. That is available here. So variance between the factor for primer divided by within the factor.
Yeah.
2.29 by 0.08. That is 27.85. All of you understand how do I get 27.85?
Yes.
Then for the next factor, which is painting method, 4.9 divided by 0.08, which is 59.7. 0.12 divided by 0.08, which is 1.46. Now that you all have F score, now the F score must be compared against the tabulated value to understand the significance. To understand the significance, we must compare the F score against table value. using the table value is a very, very old method. The recent method is convert your statistics into p-value. Convert your statistics into p-value. There are methods. There are methods by which you can convert the statistics into p-value. F-score is converted into p-value for all the factors. Now tell me, is this p-value more than 0.05 or less than 0.05?
Less than 0.0.
Less than.
Less than 0.05.
Because
That means
10 to the power of minus 5.
yeah, that means primer effect is significant. Second one, method, that is also 10 to the power of minus 0.06.
Minus 6.
That is also significant. That means
Yes.
painting method also significant. But interaction is 0.26.
Yes,
That
not-
means interaction is insignificant. Interaction, you don't have to worry about interaction. If interaction also becomes significant, you should take a decision whether you allow the factor to interact or don't want to allow the factor to interact. Accordingly, we will develop the solution. But here in this case, interaction is insignificant. So now I am going for a diagram known as interaction plot. I am going for a diagram known as interaction plot, which is nothing but primer is shown in the primer 1, primer 2, primer 3 is taken in x-axis. The color of the graph indicates painting method. Blue means dipping, red means
Dipping.
spraying.
Spraying.
Now, yeah, now primer 1, connection, internet connection unstable. I think my connectivity is poor now. Let me wait. Is it okay now? Is it better now? Is it better now? Is it better now?
Yes.
Okay.
Yes,
So here
yes,
and there,
yes.
there is pass. Sir.
Yes, yes.
Okay. 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 So now the first point is primer 1
No, sir.
dipping. Primer 1 dipping. Primer 1 dipping. How many experiments you have conducted? Primer 1 dipping. How many experiments you conducted? Primer 1 and dipping. How many experiments you have conducted?
Three.
Three.
The average of the three values is this point. You can see here. Clear? Similarly, this is primer 2 dipping. This is primer 3 dipping. This is primer 1 spraying. This is primer 2 spraying. This is primer 3 spraying. Now tell me which combination gets you a higher adhesive force in average.
Spraying.
Primer 2,
Yes. Primer 2 is
primer
high.
2,
Primer 2.
and
Spraying.
painting method, spraying.
Spraying.
That is the best solution according to the experiment you have conducted. According to the experiment you have conducted, this is the best possible solution where your adhesive force is getting maximized because you want maximum. So now all these calculations you don't have to do manually, but I only explained you for your knowledge. But it is better to use all of this with
Minitab.
Minitab. So let me show you. Open the Minitab. Have I shared this file in your group, BB33?
Yeah, aeroplane.
Aircraft. Yeah, I have
Yeah.
already shared. I will
You
open that. Just give me a minute. So maybe after I do, you people can, one of you can also try so that DOE become easy for you. But all the terminologies you now understood. So I'm sharing the complete screen so that you can see me, what am I doing. So I'm going to the folder. Training. Yeah, aircraft primer and paint. I'm opening this file. It will take some time. Okay. Yeah, I let it open. So any questions so far? I'm sorry for the poor
No.
connectivity, but if there are any questions, please ask. No one, right?
No.
So that
Yeah.
means so far,
We need
whatever
not go into the details what you explained, right? If we have a mini type, we can just look at the graph and we can
Very true.
understand.
Very true. Very
Okay.
true.
So
yeah.
only, this is Naveen here, only where I could not understand is the degree of freedom. Maybe I'll connect with you later. I don't want to disturb the flow.
I think there is connectivity issue. Sorry, Naveen, you have to repeat your question. You are please.
Sir, just I have some, I could not understand the degree of freedom, honestly.
You're
So,
asking something. Oh.
degree of freedom.
Can I come? Hello? Am I audible? Can I come?
Yes, sir, you are audible.
Yeah. So,
Naveen sir, you please repeat your question.
No, degree of freedom. He's asking degree of freedom.
Okay, you explain, sir, please.
Please note, you have, there is a 4 chairs. There are 4 chairs, right? And there are 4 people. First person goes there. He has got the degree of freedom. Yes or no?
Yes.
Yes or no? To select
Yes,
any
sir.
chair.
Yeah.
And then second person comes. Now, how many chairs are vacant? 3 chairs are vacant. He still has a degree of freedom. Yes or no?
Yes, sir.
And another person comes. Gopal Shivkumar comes. Now, is there a degree of freedom?
Yes.
Now, RK comes. Has he any degree of freedom?
No.
Only 1 chair available.
So, n-1 is the degree of freedom. That's all. Think. Right. Understood?
Understood, sir. Thanks.
That means degree of freedom means it can vary, variable, but one has to be taken its spot. That's called degree of freedom. Right? Thank you. So normally n-1 is the degree of freedom. When there are 2 factors, accordingly it will vary. Right? Thank you.
So understand all of you degree of freedom?
Yes.
Yes.
Very good. So now let me share the Minitab screen. Please confirm, can you see my Minitab screen?
Yes. Yeah.
Yes.
So data is available and Minitab requires the data in a particular format. In this format, you have to have, and now I will also tell you how to create this, but right now it is available. Now we need to analyze. So go to stat, go to DOE, go to factorial DOE. Why factorial? Factorial means all possible combinations are tested. How many combinations possible for a 2-factor with 1 at 2 level, 1 at 3 level? 6 combination possible, right?
Yeah.
All 6 combination we included in our experiment. So our DOE is known as full factorial DOE. Means all possible combinations are experimented. If you do only part of it, then it is known as partial factorial. But what we are currently discussing is full factorial DOE. Is that clear to all of you?
Yeah.
Stat, DOE, factorial DOE, analyze factorial design. Stat, DOE, factorial, analyze factorial design. Now you come here. Click the response, I mean this box, and then select the adhesive force. Now the terms you want in your DOE. What are the terms you want? See here, you can go with, first order terms, or you can go with second order terms. When I choose 1, that means I want to talk only about main effect. When I choose 2, in addition to the main effect, I am also including interaction effect.
Yeah. Interaction.
If there are 3 factors, there will be an option called 3 here. Do you understand? There will be an option called 3 here. That will include ABC on the right side. All of you understand? First order, first level interaction, I mean, two-factor interaction and three-factor interaction is also possible. Now this is two-factor interaction. This much is enough. Okay. And then one more. Okay. Now the equation has come. You can see. Can you see the ANOVA table here? Can you see the ANOVA table? Whatever we discussed, the same table is appearing here. Can you see that, all of you?
Yes, sir.
Yes, yes.
Now, primer p-value is less than 0.05, significant. Painting p-value less than 0.05, significant. But interaction more than 0.05, insignificant. All right. And everything is available. The model we have selected is linear. And according to that, I mean, linear means we have selected only the x, only the x terms. There are no square terms we have included. So this is the thing. Now, one more thing what we need to do is, and all the headings will also carry, many things. The factors, levels, and all, they're all appearing here. And now, after the ANOVA, can you see a model summary here?
Yeah.
Model summary. The model summary says your R square is 90%. That means your model is really good. Minimum requirement, you remember we spoke the last day. It should be minimum 80%. But here it is 90%. Now there is something called adjusted R square. What is adjusted R square? Adjusted R square is an improved version of your R square. The improved version of CP is CPK, isn't it?
Yes.
Yeah. So again, network connectivity issue. Network issue, I could see. Let me wait. Yeah. Is it better now? Should be better. Is it better?
Yes.
Yeah, yeah.
Am I better? Am I
Yes,
audible
yes.
now?
Yes.
Yeah, I'm audible, right? Okay. So R square is there, adjusted R square is also there. CP is there, CPK is also there. Which one you will use? If I give you CP as well as CPK, which one you will use?
CPK.
CPK. Similarly, when you have adjusted R square, please look at adjusted R square, not R square. This is improved version of your R square. Right? So this is the best indicator. So this is also above 80%. So your model and assumption, everything holds good so far. There is one more thing called predicted R square. Predicted R square is how much? 79.29. That means, can I use this? Can I use this equation? What is the equation? Equation is here below. There is an equation, regression equation. Can you see? Regression equation, you all can see, right? So this equation, the quality of the regression equation for prediction purpose is only 80%. How much it is? 80%. The more is better. If it is above 90%, then you don't have to do the experiments in the future. Straight away, the equation can be used for prediction purpose. However, here it is telling you that the predictability is only 79%. That means 79% is your confidence level, I would say. 79% of the time, your prediction will be correct, but the chance of error is 21%. And now, let us also plot that interaction plot graph. Can you see line plot?
Yes.
Go there. Now, one y variable. We have only one y variable. What is our y variable? Adhesion force. Choose this. Now, what do you want to plot? You want to find out the combination. You want to find out the combination that gives better average adhesive force, isn't it? You need better average. So I choose average. I choose average. Now graph variable. Graph variable is adhesive force. Your X variable. One is primer.
And primer.
Another X variable is painting method. Painting.
Hmm.
This is enough. Now you give OK. Are you getting the interaction plot?
Yes.
Yeah.
Every point represents the average adhesive force at that combination. 6 combination, 6 average available. Which average is better? This average is better. Primer to spraying combination. That is the optimum solution in your case, in this experiment. Is it clear to all of you? Now I want one of you to do the same thing by yourself. Then we can talk about your questions, right? Your doubts will be clarified. RK sir, if you are available, you also please come on, so that lot of network issue I am facing. So you can also answer if they are asking questions. At least one of us will be able to listen to them continuously. So who is ready to share and do the analysis by sharing your screen?
Sir, I will share.
Yeah, please. So you need to have the same, open the same file, the DOE aircraft issue. Very good. So you have the data available. So you can straight away analyze now. Go to stat. DOE factorial. Analyze factorial design. Adhesive force and terms. You can go up to 2 terms. Very good. If you don't want interaction, you can make it 1. If you want interaction, you can make it 2. So make it 2 and then give OK. Again, you can give OK. Now your Anova is done. You can see the all the terms in the Anova appearing. And to certain extent, we discussed about how to calculate them. Right? At least to understand the terminology that is required. That's why we discussed. The same result is coming here. Then you can also plot. So the same significance is indicated in Pareto also. There is a critical line drawn. Only 2 factors are going beyond the critical line. Can you see that? The main effect is going beyond the critical line, and so they are considered significant, but the interaction is insignificant. That's why we are ignoring. Similarly, you can plot the interaction plot also. Graph. Yes, one y variable. And then you can choose mean. Yes. Adhesive force, primer, painting. Very good. That's it. Painting. And then you can give OK. And now that will throw the result. Now you can take a decision. So this is the combination that is suitable. And now all of you can ask your question now about DOE, and RK is also available. I am also available. Do you now have an idea of how to conduct DOE? Tell me.
Yes, sir.
Yes, sir.
Imagine you have a y variable. You want to optimize your y variable. And there are 3 factors involved. There are 3 factors. One is pressure. Another one is temperature. Another one is velocity. Can you see all the 3 are continuous variable here, isn't it?
Yes.
All the 3 are continuous variable, and your output y variable may be the strength of the material. The strength of the material. So output is also continuous, and you have 3 factors. What are the 3 factors? Pressure, temperature, velocity. Now pressure can be low, medium, high. Temperature can be low, medium, high. And the velocity can be low, medium, high. When I say low, you have to give a value. 0.5 bar is low. 0.75 bar is medium. 1 bar is high. So 3 factors, each at 3 level. Totally, how many experiments you have to perform minimum? How many experiments you need to conduct now?
27, sir.
27. But there is a principle, important principle that demands replication. When you are doing DOE, there is a principle called replication. Imagine the replication is 3. It can be 2 also, 2 or 3. If it is 3, what will be the total number of experiment?
27 into 3.
81.
27.
81 experiment. And 81 experiment, you can't do it in a day, isn't it? You can't do it with just one team. So you may plan for multiple teams conducting experiment on multiple days. So blocking is happening. Can you see that?
Yeah.
Now what is that you need to take care? Blocking must be homogeneous or
Homogeneous.
it can be
Homogeneous.
non-homogeneous.
Homogeneous.
That's how you can prevent blocking becoming a factor. Otherwise, block will become a factor, right? Don't do that. Blocks must be homogeneous. And inside the block, let's say you are going for 9 blocks. Each block will have 9 experiments. These 9 experiments, can I conduct in the same order?
Randomized.
Random.
Randomize. The order of experiments inside each block must be randomized. Why it is required? To minimize bias. Very good. So now that you did 81 experiment, 81 readings are available. You remember our discussion. Row wise total, column wise total, sum of squares, total sum of squares, correction factor, degree of freedom. So many things will be happening. And then finally output will be in the form of a table that is known as Anova table. That is known as Anova table. Anova table will convert the F score into p-value. Will convert the F score into p-value. Finally, you can take a decision with the help of p-value, and then by going for a interaction plot, you can understand which combination is best working for you, and then you can take a decision. Is it clear to all of you? Will you be able to do it the same way?
Yeah.
That is good enough. And any specific question? RK sir, you want to add something in any
Sir,
other point?
Sir, one question here. So especially the order of experiment within the block. That means how do we find out that how many experiments have to be conducted in each of the blocks?
That's what. See, that is purely depending on the constraints.
Okay.
Imagine you want to make a cake and then sell it. You want to make a cake and then sell it. And you are doubtful about 3 factors.
Okay, sir.
You have the clarity about many factors, but 3 factors you are doubtful. Amount of milk, how much to add, you don't know. Right? And then baking temperature, you don't know how much should be the baking temperature. So one is temperature, another one is amount of milk, and one more thing, let's say, the amount of butter. Now 3 factors you want to optimize. Now tell me, amount of milk per kg of per kg of cake. How much milk normally people add? Per kg of cake, let us say 750 ml to 1 liter. Too much milk, right? So that's why process knowledge and some subject matter expertise is required. If you know some idea about the process, you can carefully choose your range of investigation.
Okay.
The range has to be, the narrower is better. Range has to be, narrower is better. Let me say, the correct range is, let's say 300 ml to 500 ml. Now there are possibilities. I can make cake with 300 ml of milk. I can make cake with 400 ml of milk. I can make cake with 500 ml of milk. So how many levels are there in my study? 3 levels.
3 levels.
So for milk, 3 levels. For butter, let's say 3 levels. And then what is the one more thing I said? Baking temperature. Let's say baking temperature, I have again, 3 levels. 3, 3, 3. So that means you have to make 81, 3 into 3 into 3, 27 cakes.
27.
And replication is 3. 27 into 3, 81 cakes
81.
you have to make. Now Vineet and his wife will be making 81 cakes according to the experiment. Vineet, will you be able to make all the cakes in just one day in your house?
No, sir.
Not possible.
Tell me how many days you will complete, or
Next day, we need come out.
do you need any help from other faculties here? Yeah.
I need
Now what?
it.
Yeah, you will outsource. So blocking will happen automatically. Suppose if I am also come to help, then you will expect me to make half of the cake, isn't it? So
Right.
we will be dividing, 40-40. Now
Oven is
the
also
me-
required now, sir.
Yeah,
Extra
oven is
one cake.
also required. All these things are called constraints. Now, whatever procedure I follow and procedure you follow should be same.
Should be same. Yeah.
Then only it is homogeneous. Then only it is DOE. If I make cake in my own method and you make cake in your own method, there is no point of trying to optimize something. Blocks have to be homogeneous. If I make all the cakes in daytimes and you make all the cakes in evening time, is it homogeneous?
No.
No.
That is also a mistake. So we have to first of all make our blocks homogeneous, and then after homogeneously creating the blocks, inside every block, you need to randomize your trials. In a day, we have decided to make 9 cakes. And we have to number each cake. Please note, cake number 1, cake number 2, cake number 3, isn't it?
Yes.
So 1 to 9. 1 to 9, every cake is a unique combination of factors. Am I right? Every cake is a unique combination of factors. So the order of making the cake must be randomized. Must be randomized. For example, you put 9 numbers in a box. Choose one number out of it. The number is 8. So your first cake you and your wife making on the day is cake number 8. Your cake making process is randomized. Am I right? Now one more slip you will take. Now that will say 3. So the third formula will be used. This is called randomization. Understand? Or otherwise, Excel can generate a random number. Excel can generate a random number. Or Minitab can do all the job for you. See here, I'm sharing Minitab. Go to Stat. Go to DOE. Factorial. Can you see something called Create Factorial Design?
Yes.
Yes.
Click that. And now 2-level factorial. Okay, this is for 2-level factorial. And we choose general full level factorial. Number of factors 3. And display design. Okay. Factor A. I'm just typing something. Temperature. Temperature. Okay. Pressure. And then velocity. Whatever it is, number of levels 3. Number of levels 3. Number of levels 3. And replication 2. Okay. Block on replicates. Okay. I give. Okay. One more. Okay. Can you see Can you see some format here?
Yes, sir.
Your readings,
54.
you can type your readings here. See here, totally how many experiment?
54.
54 experiment in this order. Can you see that this is called random order? In this order. 54, this is random order. Random order means the first experiment, temperature at level 1, pressure at level 3, velocity at level 3, because you have given 3 levels for each factor. All of you, are you with me?
Yes, sir.
Yes.
When I say when I declare the factors, the levels and the replicates, Minitab gives me a format. According to the format, the principles of DOE is followed. Now you just have to conduct the experiment as per this format and complete 54 experiment. Now, once you type all the values, then probably no, it is ready to analyze. Now values are available. You can analyze now. Stat, DOE, factorial, analyze factorial design, readings, terms. Now why 3 is coming here? Because there are 3 factors, right? Am I audible?
Yes.
Yes, sir.
Yeah. So 3 means all the factors will appear on the right side. 2 means up to 2 level interaction. 1 means no interaction. I want everything. This is a random thing we are doing. Okay. And then one more okay. Now the analysis is done. This is now the job of conducting the DOE, analyzing the DOE has become much easier with the assistance of Minitab. That's how it is. So questions and RK's additions will happen now.
First, I'll wait for the questions. Then I'll ask questions.
Sir, one question. When you took
Yeah.
up when we did the DOE, when you went to the create factorial design, sir, in the factors, you type temperature, velocity, and pressure. Then any changes you did in the type or anything, sir? Because 54, when I did the same thing, I'm not getting. That's the reason I was asking.
No. Maybe I can repeat. You can carefully watch.
Yeah.
So go to stat, DOE, factorial. You see create factorial design.
Yes, sir.
You create. Then select general full factorial.
Okay.
Then number of factors you can give here. If I give only 2 and then design, I can choose the design.
Okay.
Now in the design, it is asking me to give the name of the factor. I can type anything that I want. Primer and then painting method. And primer 3, painting method can be 2. Number of replication, now this time is 3. And I'm just taking this blocks on replicates. I give okay, one more okay. Can you see the format now ready?
Yes, sir.
Yeah.
This will have all the required combination. Totally 18 experiment. If after conducting the experiment, if I type the adhesive force here, once I have the values here, my data is ready for analysis. After analysis, the decision making is already mastered, which is, hypothesis testing, Anova or whatever. Depending on the type of data, the DOE automatically, conduct the Anova and then that will throw the result. You can decide.
Got it.
Okay. I think the session brought
Any
some
other
clarity.
question? Any other question? No other question. I will just tell you, probably I would like to ask you a few simple, small questions only. I have not given the answers before. Please, normally I used to tell that I give the answers and then ask questions. Now it's not like that because Gopal Shikumar has already explained you all these things. Now, what is DOE stand for?
Design of experiments.
What is design of experiments?
Minimize the optimum.
No, no,
Minimize the experimental error.
Weighing the factors influencing the process
Design
simultaneously.
of experiments.
No. Design of experiments is just, is there a difference between run and experiment? There is a difference between run and experiment. Each test you are conducting is called run.
Run.
Understood? And the number of runs put together is called experiment. Clear? Understood? Right. When I say design of experiments, how many runs are required and what are they? That is called design of experiments. Clear? Understood?
Yes.
Yes.
Suppose I say that I consider a factor temperature and pressure. How many factors are there?
2 factors.
And I consider low temperature and high temperature, low pressure and high pressure. How many levels are there?
4.
4.
How many levels are there in each factor?
2.
So
2.
we call it as 2 factor, 2 levels. So the experiment consists of how many runs? 2 power 2.
2.
Love
Four.
failure.
4.
L power F. L stands for
Level.
level. F stands for
Factors.
factor. This is what I call, Harita, brilliancy. I said love failure. No, you don't remember the love failure. You remember that in context with the design of experiments, it is L power F. Very good. That is what the change I want at the end of the course, right? I may teach any nonsense, but you'll have to grab only the correct part of it, right? Thank you very much. And then, this is what is called design of experiments, right? Temperature L1, pressure L1. That is one run. Temperature L1, pressure H1, high one, right? That is second run. Third one is temperature high one, pressure low one. Fourth one, temperature high one, pressure L1. This is called the design of experiments. Nothing more. Understood? On design of experiments is the first step. Understood?
Yes.
And then comes what is the step? You don't do that in the same order. You don't do that in the same order. What is that order you follow?
Random order.
Randomization.
Why do you follow the randomization?
To find out the error.
Minimize bias.
Minimize error.
Yeah. Minimize bias.
Minimize the bias.
Find out error, bias and all, nothing, yeah. I tell you, what is the effect of certain factors I don't want. The effect of certain factors, I am not at all interested. Right? Therefore, I do the randomization. Like, for example, I consider speed. Speed. So I have to conduct the experiment at 3 speeds. Levels is 3. Low level, medium level, and high level. Right? Now I have to conduct the experiment. It has given the order. So therefore, what I do is I first do the experiment at low speed. Then increase the speed to medium level. Then increase the speed to high level. And then conduct the experiment. It gives the result. Then my operator comes and tells me, RK, you are a fool. I tell you it is going to give you a best performance at high speed. Whereas because you are doing like this, the high speed has got lower performance. I'm confused. What is it? Always operators are much better than me. Right? See, it is getting heated, yeah. Don't do like that. You don't do that experiment in that order. Give some time, do some other experiment and bring back and then do this experiment at high speed. Yes or no? Therefore, what I do is I randomize. I first keep it on speed, change pressure next, and then come to the high speed, and then change pressure next, then come to the high speed, and then do the experiment. Clear?
Yes, sir.
Understood?
Yes.
Then comes what? Randomization. Then comes blocking. What is the purpose of blocking?
Homogeneous.
You cannot do all experiments in one shot.
Very good. That is one aspect. Because operators may not be there. That particular component may not be there. All these things. Then just because he is not coming, what should do? We should not conduct this experiment. Huh? We cannot conduct the experiment even if you want to. Then what should we do? What should we do? We should think.
Not
Yes or no?
audible, sir.
We should think and then avoid the experiments which are not going to be, I'm not going to be interested in it. I'm not going to be interested in it. Like for example, I got 2 replicates. You know, the human made 2 replicates. Replication is 2 means, you know, understand what it is? Yes or no? I have got an experiment, design of experiments I got. I want to do it once more. Yes or no?
Yes.
Why do I
Yes,
want
yes.
to do it once more? So
Take
that
accuracy.
the same thing. No, I don't want to have that noise effects removed. Right? But I have got only 6 hours a day. I have got only 6 hours a day. Therefore, the total experiments, how many days I need? How many days I need? 2 days.
2 days.
Because 6 hours I can do on it. So what I do, I first do the experiment of the first replicate first day, second replicate second day. Yes or no? This is again
Yes.
a blocking. Here, what is that nuisance factor which I wanted to avoid?
Noise.
The day.
Noise.
The day.
Day.
Right? If I mix it up, because of the day effect, I will get a wrong result. Therefore, I want to group them in that way. And this is called blocking in a particular aspect. I want to eliminate the effect of day. Nuisance factor is day. Like for example, the nuisance factor is labor. The nuisance factor is the factor material itself. Then I have to avoid that and then see that. Like for example, I am not interested in the interaction effect of A and C. Interaction effect of A and C. Therefore, what I do is I conduct the experiment only where the interaction effects of A and B is there. Understood? I will not include that C in this today's experiment. I will block it separately because I don't want the influence of C on A. I don't want the influence of C on B. This is what I have to think and then do the blocking. Clear? Understood? I have got limited experiments to be done. Therefore, I do a blocking. Why do I want to do a limited number of experiments? Because of constraints. What are the constraints? I do not know. Right? Depending upon the constraint, I have to do the blocking. Clear? Understood? So you have understood what is design of experiments, what is randomization, what is replication, and what is blocking. Clear? That means you have done, you know everything about DOE. Then what is the deliverable of DOE? Yeah? What do you get out of DOE? No, we are talking about each step and then each phase, and then this is the deliverable. What is the defined phase deliverable? We all know project charter. What is the deliverable of the measure phase? We all know gap or baseline performance. What is the deliverable of,
decision making.
Yeah. What is decision making? Decision making is not deliverable. Yeah. I make a decision. Is that you are happy with that?
No.
So based on statistics, what we proved.
Yeah. Yes. What is your aim ultimately? The deliverable of DOE is what? When does the DOE end? Tell me.
P-values.
Hello. We are all talking like a student. We are all professionals, right? We must have an aim goal in our thing. Yes or no? Right? We should never forget our goal. Never ever talk about, yeah. See, even the students will not like, if we talk about p-value, we will talk about this thing and that thing. No jargons, nobody likes.
Minimize the defectiveness.
Huh?
Minimize the defectiveness.
Minimize the defectiveness. So you don't want anything, no?
Improve the optimization.
Yeah. Very good. You want?
Improve the
You want to have
optimization.
what you want. Every
Optimization.
one of us want to have what we want. Yes or no?
Yes.
I want this. I must get that. In order to get that, I must keep this factor, that factor. So I'll have to keep that factor. I'll have to optimize the factor depending upon the resources available. Then, so what is the deliverable of DOE? The deliverable of DOE is the model. What is called? Model. Understood? What is model? Model is something which everybody hates. I also hate. Model is an equation called regression model. Right?
Yes.
Y is equal to mx. What is X factor? X factor is availability of RK. right? M is, and what is M? Slope. Right? Now, if RK's availability of this thing is X is 6 hours, what will be the quality Y? Worst. Yes or no? You will not get what you want. You want RK's effect 10 minutes. Clear? Am I right? So Y is equal to Mx optimum, then it increases and then it decreases. Therefore, it may be a second order or third order. So this equation you got. This is what is obtained in the case of more factors, not only RK. Gopal Kumar is there, Ravi Kumar is there, Vivek Kumar is there. All the factors are there. Then the overall course performance depends on all these factors. So that RK should take about 10 minutes. Gopal Kumar should take about 2 hours. RK, who is that? VK. VK should take 1 hour, like this, right? Understand? This is what is called a model. So the deliverable of DOE is
Model.
model. And then does it end with that DOE?
No.
No. Yes. What should we do?
Again do
Yes.
experimental.
Again do plan, do, check and right. So keep this from this model depending upon what you want. Right. We can't keep this black belt course for another 1 week. Yes or no? So we have to stop this week. So we'll have to find out what is the time period or what is the factor I should keep. What is this factor at what level I should keep. And then do the experiment and then verify that what you want is obtained or not. Yes or no?
Yes.
Then comes the DOA ends satisfactorily. If it doesn't come happily, then what you should do? DOA
Again
should be
do-
done again. Right? Okay.
Yes, sir.
Till you get what you want. So they never ever stop till you get what you want. Right? That ego should be there, that goal should be there. Then you will get it. All the best.
At the same time, it will consume your resources and you have to be optimistic. Right? So time is required, money is involved, effort is involved. And so you have to design it and do it. Now, before even we go for the lunch, I wanted to just discuss one more example. Imagine, let us again imagine a hospital scenario. See, normally the mother carrying a baby, they come for some routine check. Am I right? Am I audible?
Yes, sir.
Yeah.
Yes, sir.
So why do they come for the routine check? They want to understand the growth of the baby, isn't it? So one important metric to understand the growth of the baby is the weight of the baby. At the time of birth, it should be around, what is the ideal range? I mean, optimum range?
2.5 to 3.
3.2
2.5.
maximum.
2.5 to 3 kilo.
So yeah, 2.5 to 3. So sometimes if DOE means, we conduct experiment and then get the readings and then we make a model out of it. But these kind of challenges, real-time challenges, whether the baby's growth is normal or any abnormal growth or a shortage of growth is there, the doctor want to understand. So that's why they do some scanning, and then even before the baby is born, they get an estimate of the weight of the baby. Am I right?
Yeah.
Yes.
How
yes.
do they get the weight of the baby? The baby is yet to born. How is it possible to get an estimate of the weight of the baby? First of all, the weight, whatever doctor is getting, it's not accurate weight. Am I right?
Mother's weight.
Yes. Yes. No, including water
Because the mother,
content.
mother, baby, water, so many things are together. So whatever they get, it's only an estimate. It's only a statistics. It's only a prediction. They have some equation helping them. That equation is nothing but regression equation. What are the factors which are significant to the weight of the baby? The doctors here can guide me better. What are the factors that can be significant to the weight of the baby? Come on.
Amniotic fluid.
First of all, the duration, isn't it? Whether the baby is 3-month-old or 4-month-old or 5-month-old, isn't it? That's an important factor.
Yes.
Age.
Then
Duration.
Then the height of the baby inside, I think that can be measured. Yes or no?
Yes.
the scanning images, etc. No, you get the height of the baby, the diameter, etc., etc. So these are certain factors significant. With the help of these significant factors, the weight is estimated. That means a regression equation is working behind, and that is throwing the weight as the output. Yes, sir. So how are you going to use this knowledge? That purely depends on your understanding on the tool, and as well as understanding the scenario. And you can't do a DOE there, design of experiment, isn't it? That's a natural process. Mother giving birth, it's a natural process. There you can still develop the regression equation with the wealth of data that is already available. The same hospital helped so many mothers. The weight of the baby is taken and several readings are available, isn't it? Yes or no? Am I audible?
Yes.
Yeah. So with all those readings, you can develop a regression equation, and that regression equation can be used to predict the weight of the baby. So that such example I am having right now. You see screen, right? Can you all see my Minitab screen?
No.
All of you, can you see my Minitab screen?
Yes.
Yes,
Now.
Yes, yes.
Now.
That means the connection is very slow. See here, height and weight. Height and weight. Some information is available. The height in centimeter or millimeter. I think it is millimeter. So the height of the baby is available. Weight of the baby is also available. With this, both are continuous variable. Am I right?
Yeah.
Both are continuous variable. So I'll go for a regression. Go to stat. Go to regression. Go for fitted line plot. Y is, which is Y here? Weight is,
Wait.
height is predictor. Now relationship, whether the relationship is linear, quadratic, cubic, we already studied this. So I just give okay. Now, beautiful regression. Can you see here? Is this regression very strong?
Oh, it is not yet displayed.
Or is there a problem?
Not yet displayed.
Oh, it is not displayed.
Not yet.
Yeah. Yes. Now it is.
Line
It
chart.
takes a lot of time. Now it is visible. Now the regression is really a strong regression. Can you see here?
Yes.
Yes.
Yeah. The
Linear
adjusted R square is 99%. Adjusted R square is 99%. That means it's really a strong regression, and model is really good. Our linear model, and the significant factor is height of the baby inside the mother. That's a significant factor. So once that height is available, then the weight of the baby can be predicted. So now going to session window. Okay, let me go in this manner. Stat, regression. There is one more option, regression, fit regression model. In response, you choose weight. In the continuous predictor, you choose height, and model.
Screen is gone, sir.
Sharing is stopped.
I'm sorry, I think connect again.
Network.
At least, is it better now?
No, your screen is
Yeah, now
not
it's
visible.
Better now?
Now it's gone.
Yeah. I will just repeat again. So go to stat, go to regression, go to
Sir,
this
your screen is
regression,
not visible.
fit
Yes.
regression model.
Sir, your screen.
Oh, video is not visible.
Share screen.
1 minute. No, screen. Okay, I'll change the network. Just give me a few seconds. I'll share. Just a second.
Yes, good.
Should be visible, right?
Yes.
Yes.
Yeah. So go to stat, go to regression, regression again, fit regression model. Y variable is weight of the baby, X variable is height of the baby, and then model is linear model. 1 means linear model, 2 means quadratic model, 3 means cubic model.
Cubic.
Anything can turn out to be the best model, but right now I want to go with 1. I give okay, 1 more okay. Now the regression model is generated. Can you all see? Can you all see the regression equation?
Yet to come.
Yes, yes.
This is nothing but the one we have studied, y equal to mx plus c. Linear model. And now, yeah. Okay. 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 So we just got the regression equation. Now, when you have sufficient data, any regression equation model generated in Minitab, that will give model summary. Can you see model summary here?
Yeah.
Can you see
Yes.
the model summary?
Yes.
Actually, model summary is not generated for the current data. I am referring to the previous one. When the predicted R square is better, I mean more than 90%, you can understand your regression equation is ready for prediction purpose. Your regression equation is ready for prediction purpose, which means suppose if the baby's height, let me type something here. If the baby's height is equal to, let me say, let's say 40, okay, let's say 85 millimeter. What will be the weight? This is my question I want to understand. If the baby's height is 85 millimeter inside, what will be the weight of the baby? Now this question will be answered by your regression equation. The equation is available here. You can substitute here so that the weight of the baby in grams, you will be able to understand.
Yes.
But how good is your answer? That you need to refer to the R square value here. Right? All of you understand? So the
Yes.
same thing is, information is available in my, what do you call, slide also. You just have a look and then we can wind up. Can you see here?
No, sir.
Yeah.
Yeah.
Now it is.
Now it is visible. So
Yes.
height information is available, weight is available, regression equation is available. Look at the R square values. Are you happy with your regression equation? Regression model?
Yeah, 99.28.
Yes, 90.
Yeah,
90.
that means the predictability is much better with your regression. So when the height of the baby is, let's say 40 centimeter, what will be the weight? What is the answer regression equation is throwing? 1.21 kilograms. When the height of the baby is 40 centimeter, the weight will be 1 kilograms inside the mother. Tell me, that am I audible? Am I audible?
Between getting cut, sir.
Yeah. Is it okay now? Okay,
Yeah.
right? Yeah. When the height of the baby is 40 centimeter, regression equation is telling weight of the baby will be 1.21 kilogram. Does it mean the baby weight will be exactly 1.21 kilogram?
No.
No.
No. The doc, with all hope, doctor is believing that the weight of the baby will be 1.21 kilogram. But the same doctor is 95% confident. You see that?
Yeah.
Can you see that, all of you? This is called a confidence interval. And this is called a prediction interval. This is called prediction interval.
Prediction. So that means it is 0.93 to 1.5 baby
Yeah.
height.
Which is wider? Confidence interval is wider or prediction interval is wider?
Prediction interval.
Prediction interval is wider.
Wider.
Yes.
See, confidence
1.65.
interval is meant for average value. Confidence interval is meant for average value.
Average.
If you can take multiple scanning of the baby, let's say 3 scanned images. Now you have 3 readings, isn't it? Yes or no?
Yes.
Yes. So when
Yes.
you have 3 readings, the average of the 3 reading is expected to fall in the confidence interval, fall within the confidence limits. Can you see that, all of you?
Yeah.
If you can't afford to take 3 readings, it is 1 reading, then your value is expected to be inside the prediction interval. Do you understand? So always, statistics come with certain known limitation. Even though your statistics says baby's weight is 1.21, still the chances weight can be anywhere in this range. Even though you are getting an estimate of 1.21, still the actual weight of the baby inside the mother can be any value between 0.78 kilograms to 1.65 kilogram. All of you, do you understand the limitation here of your statistical analysis?
Yes.
This is knowing the limitation, you can use all the statistical tools. Clear? Now, you please answer this question. Baby's height is 60 centimeter. Now, what is the height of the baby?
60.
5.5.
5.5 kg. So, I think it is very beyond the normal range. No problem. Let's not worry about it. Now, what does it mean? What does this prediction interval mean? If you get 5.51, what will be your decision now? The weight of the baby inside the mother
Will be in the
can
range of
have a weight
5.17 to 5.8.
5.17 to
1 to
5.85.
Yes.
As a doctor, you should know, yes, this will be the range of the weight of the baby in the mother. In order to use the confidence interval, you must take multiple readings, and the average you can expect in this shorter range. If you go for the average, the advantage is the range will reduce, the interval will reduce, so that your prediction is becoming better and better. Clear, all of you?
Yeah.
By doing so many experiments, we finally wanted to build a model which can help in taking more effective decisions.
Sir, I have one question. Hello.
By you can optimize your result. Result means your Y variable. But I think you are able to learn. Yeah, please.
These three values. One is SE, another one is CI, another one is PI. So
What is
normally,
first one you said? What is first one? SC, yeah?
SE,
Standard error.
standard. No, I think. Can you show?
Yes, who is speaking? Saravanan or Sivarajan?
Saravanan.
Yes, sir. Can you show the slides once again? Yes. Sir.
1 minute, 1 minute. The same PowerPoint. This one?
Yes, the last one.
Correct?
No.
Not,
Yeah.
yeah. Now
Yes,
it is
sir, yes.
visible.
Now, okay. Yeah, that fit and the SC fit. So normally we go for a PI, correct?
Yeah. See, single observation is expected inside prediction interval.
Okay.
Average of your readings is expected inside confidence interval.
Okay.
And the standard error of the mean. So this is standard error of the fitted value.
Okay.
Fitted value means Y value, and the standard error is this.
Yes. So always we go for a PI.
Yeah, prediction interval, because wherever multiple readings are not possible, then you must use prediction. Can be conducted. Then you can expect the average and use the confidence interval. Right? Good. So shall we stop here for the lunch?
Okay.
Yes, sir. Yeah. Yes.
Shall
Okay, sir.
here for the lunch?